Hello everyone, I'm Dr. Anantharaj Sengeni. I'm an electrochemist. I'm currently working as a junior researcher at the Research Institute of Science and Engineering, Waseda University. As an electrochemist, my research interest revolve mainly around the electrochemical conversion of small molecules into fuels, other value-added products, and electrical energy. I primarily develop electrocatalysts using electrochemical anodization and wet chemical methods. The catalyst I have developed so far have been utilized for the production of hydrogen fuel from water and also from water and other small molecule co-electrolysis. When we talk about hydrogen as a fuel, we need to understand the need for hydrogen, because we know that in the past few decades there has been excessive and uncontrolled use of oil and gas that have been polluting our environment by releasing more and more carbon dioxide into the environment. So we need a fuel that will not harm our environment anymore. In that context, hydrogen is the most promising candidate. It can be produced in several ways, including the methane reforming and also water electrolysis. But water electrolysis is more advantageous when we consider the environmental effect. Particularly when we combine the process of water electrolysis with the energy harvested from renewable sources, the hydrogen produced by this method is called green hydrogen because it does not cause any harm to the environment while it was produced. Water electrolysis is an energy-intensive process that requires highly active electrocatalyst with minimum energy requirement. I work on this area focusing on both the half-cell reactions of water electrolysis, which are the anodic oxygen evolution reaction and cathodic hydrogen evolution reaction. In developing highly advanced electrocatalysts, I rely on two strategies. One is the in situ activation of electrocatalysts, the conventional electrocatalyst, and the second one is the self-supported catalysts that offer high activity and excellent stability because of the high catalyst loading and atomic level binding with the substrate when we compare the same performance to that of conventionally modified electrodes. Not only that, as an electrochemist, I feel obligated to help fellow researcher by recommending and advising the best practices in screening electrocatalysts, not only in water electrolysis, but in almost all energy conversion reactions. Because electrochemical energy conversion reactions involving the conversion of small molecules into fuels and the conversion of fuel into electrical energy has now become an interdisciplinary field in which experts from many different backgrounds work together. As a result, most of them lack in fundamental knowledge, electrochemistry knowledge required for this field. So as a core electrochemist, I continuously write viewpoints, research articles, and perspectives that are recommending the best practices to screen the electrocatalysts used in these electrochemical energy conversion reactions. When it comes to international level collaboration, I have an extensive network, particularly Professor P. Sudhakar of Harriet-Watt University at UK, in the UK, Professor Sungchul Yi of Hanyang University in South Korea, and Professor Prashant Manases of TU Berlin in Germany are the important ones, and they have been helping me a lot in understanding the works what I have been doing, and recent collaborations have been ended up getting published in highly reputed international journals. So when it comes to reaching out to the younger generation and to the general public beyond publication and conferences, I believe that with the level of cyber influence we could have these days, there are more than one ways. So as an example is my Let's Speak Electrochemistry online discussion series. This is a recurrent online event in which I discuss electrochemistry and clarify doubts with the emerging leaders of the field. You can find more information and recorded sessions of this EChem online discussion series in these websites. So I believe methods like this could help us disseminate research results to the general public and to the young generation of this field in a more efficient way. As an early career scientist, I am open to new collaborations, especially I am looking forward to closely working with people who can perform DFT calculation to understand the energy of interactions of the intermediates of the reactions that I am studying with my catalyst, and also the people who are experts in the area of analyzing this electrocatalyst under operating condition. I mean, under the reactions that these catalysts are catalyzing. So I want to understand how these catalysts change their surface depending on the reaction what we study. If you are a one, please do contact me via email and I'll be happy to connect. Yes, I don't believe that I have reached a state in which I can give out advices, but I have some tips that may be helpful to you all those listening. In academia, I believe that we should follow these few things to be successful. One is never set deadlines, because science is not something we can do it by setting deadlines. We need to travel along and try to understand things. Enjoy what you do. Never compare yourself with any other in the field of academia, and be a reviewer to yourself, and you will find it very easy in surviving in this field. Thank you. I hope you enjoyed my video. I wish you all the best.